college algebra students, you are on the home stretch. You're ready to wrap up this review? We've got one more page to go. The last page of your review is focused on quadratic functions or graphing parabolas. I want you to pay attention to the two methods for finding the vertex. Problem number 39, vertex, is going to be a little different than problem number 40. Notice in problem 39, the format of the function is sort of in that factored form, and in 40, it's in the multiplied out form. So we're going to use two different methods for finding the vertex. On problem number 39, if it's in this factored out form, you can simply read the vertex using transformations. I know this is a parabola, and because I have a plus 4 inside the function, we've learned that's going to shift the parent function left by 4 units. Well, if I move left by 4, that means my vertex is going to have a value, x value of negative 4. Out here, I have a vertical transformation, which indicates I should move the parent function down 8. So my y value is going to be negative 8. So if your quadratic function is in this factored out form, you can simply look at it and read the vertex. Change the sign of the number next to the x. Keep the sign of the number outside the function. You could always graph that and double check that you have the right values for your vertex. Now, on number 40, if your quadratic function happens to be in this multiplied out combined form, we do have to know a formula. Please memorize this for your test. To find the x value of the vertex, we're going to find negative b over 2a. A, b, and c are the same a, b, and c that we found with our quadratic equations. So b is the coefficient of our x term right there. Notice it's negative. We've got a negative from the formula, and we have a negative b that we're plugging in. So I've got a double negative to simplify there. A comes from your leading coefficient. In this case, it's negative 4. So simplifying here, we have x equals 40 over negative 8, or clearly x is equal to negative 5. So the x value of our vertex is negative 5. If you remember negative b over 2a, the next part is very easy. The y value is going to be f of negative b over 2a. That just means whatever I got for the x value, I'm going to plug back into the function and evaluate it to find the y value. So we're going to plug negative 5 into our function where we see the x's. So we'll evaluate negative 4 times negative 5 squared minus 40 times negative 5 plus 84. Now, if you want to evaluate that step by step, you certainly can. You can also plug it into your calculator, which is what I'm going to do. If I make mistakes, I have a tendency to make those mistakes on my calculations. So I'm going to use my handy dandy little calculator here and evaluate. We have negative 4 times negative 5 quantity squared minus, notice I'm using the minus operation instead of the negative button. Those two steps are important. Negative 40 times negative 5, and then plus 84. Let the calculator do the evaluation. We come up with 184 for the y value of our vertex. So remember, in the multiplied out form, you can read the vertex directly from that format. In this one, we have to make sure and remember the formula negative b over 2a. Once you get negative b over 2a, you plug that number into the function and out pops your y value. Okay? We'll get to practice this again on the next problem, next couple of problems. In these cases, we want to graph the parabola. So notice on problem 41, we have this factored form for the function. So to get the vertex, I can just read it directly. The x value, remember, is the opposite of the sign that I see in parentheses. That's a left transformation. And the y value is the same sign, that I see outside the function. That's a down transformation. Once I have my vertex, I think I'm going to plot as I go. Get that one ready to go. And the equation of my axis is going to be indicated by whatever I got right there. Okay, so the equation is always going to be x equals whatever the x value of my vertex is. And this is simply a vertical line that divides my parabola in two. So when I graph it, I want to make sure I have two matching pieces. Now I'm going to hold off on the domain and range, come back and do that after I've graphed it. I'm going to jump down to the x-intercepts. Now to find an x-intercept, the plan is always set y equal to 0. Now y is the same thing as f of x. So I need to solve 0 equals x plus 3 squared minus 4. This quadratic equation will be easily solved by our square root property. So add 4 to both sides. Take the square root of both sides now that I have the quadratic part isolated. And don't forget your plus or minus, right? Square root of 4 is plus or minus 2. And then solve for x. We're going to subtract 3 from both sides. I'm going to put that right in front of the plus or minus. That's going to give me two different x values. So negative 3 minus 2 is negative 5, and negative 3 plus 2 is negative 1. That's not an ordered pair. Those are two distinct x values of two different points. Let's be official and express these as ordered pairs. Remember, we set y equal to 0. So one x-intercept is negative 5, 0. The other is negative 1, 0. If I plot these on my graph, notice they are equidistant from that axis of symmetry. 2 units on this side, 2 units on this side. So that's looking good. Now, to find a y-intercept, the plan is to set x equal to 0. You're always setting the opposite variable equal to 0. So when we plug 0 in for x in the original function, notice in parentheses there I just have 3 squared. That's 9, or 9 minus 4 gives me 5. So in my y-intercept, the x value is 0, the y value is 5. So if I plot that on my graph, got it right up there. Okay? Now that's sufficient to construct our parabola. So let's go ahead and sketch it through very carefully. Not too bad. Now we can read the domain and range. The domain, remember, is leftmost x value to rightmost x value. In this case, it's negative infinity to infinity because that parabola is always getting wider and wider. The range is going to be the lowest y value to the highest y value. Notice the lowest point I can find here is the vertex. It has a y value of negative 4. And there is no highest y value, so it's going to stretch up to infinity. Okay? Again, you can type that into your calculator. Make sure your graph ends in the right spot. Moving on to the next one, we're still going to be graphing a parabola, not by transformation, but by finding the vertex and the intercepts. Observe the format of this function. It's in the multiplied out form. So to calculate the vertex, I'm going to need my negative b over 2a formula. So the x value of the vertex is negative b over 2a. A is 1, b is negative 6. So we have negative from the formula. Replacing b with negative 6 gives me negative negative 6 divided by 2 times a, which is 2 times 1. Calculating, we have 6 divided by 2, or 3. So the x value of our vertex is 3. Now, if I remember negative b over 2a, all I have to do to get the corresponding y value is plug it back into the function. So I'm going to find f of 3 to get the corresponding y value. We have 3 squared minus 6 times 3 plus 8. Or, following order of operations, we have 9 minus 18 plus 8, which turns out to give us, let's see, 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. So our vertex lands at 3, negative 1. As soon as I've determined my vertex, I can write the equation of the axis. The equation will always be x equals, because we're describing a vertical line here, and it's going to be equal to whatever the x value of your vertex is. So this vertical line will divide my parabola right in two. Let's work on x-intercepts. To find an x-intercept, remember we set y to 0. Y is the same thing as f of x. So we need to solve 0 equals x squared minus 6x plus 8. Can't use the square root property on this one, but we can certainly factor this to find our x values. This will factor as x minus 2 times x minus 4. Setting each of those factors equal to 0, you can see we'll obtain x equals 2 and x equals 4. So expressing these officially as ordered pairs, our x-intercepts are 2, 0, and 4, 0. 2, 0, and 4, 0. Notice they are equidistant from that symmetry line, so we are good to go. Working on our y-intercept, remember the plan is to set x equal to 0 to find your y-intercept. When we do that, we're just going to end up with that constant on the end there. Y is equal to 8. Uh-oh, that one's a little off our graph. That's okay, we'll adapt a little bit. 5, 6, 7, 8. We'll imagine it up here. Okay? That's sufficient to construct the graph of our parabola. So we'll connect our dots carefully. And as always, you can check it on your calculator. The domain of a parabola is always negative infinity to infinity. The range is going to go from the lowest point to the highest point. The lowest y value here is negative 1. The highest is infinity. I better fill in my y-intercept there. So our problem is complete. Okay? You are almost there. One more problem and you are going to be good to go for your midterm exam. Number 43 says a company manufactures and sells bath cabinets. The function p of x models the company's daily profit, p of x, when x cabinets are manufactured and sold per day. So let's just make a note. X is the number of cabinets. P is profit. We are measuring dollars. Question A says, how many cabinets should be manufactured and sold per day to maximize the company's profit? And part B says, what is the maximum daily profit? Notice these words, maximize, maximum. If you'll observe our function p of x, it's a quadratic function. It's got an x squared there. And we know that it opens down because it has a negative leading coefficient. So if I just imagine the graph of that function, it's going to look something like a parabola opening down. So this question is asking me about maximum value, right? That is simply code for where is the vertex. So I need to find the x value of the vertex. That's going to give me number of cabinets. And the y value, or p value, that's going to give me the maximum profit. In the form that this function is presented, we know that we can calculate the x value of the vertex using our formula negative b over 2a. So in this case, negative b is going to be negative 150. I'm looking at the coefficient of x there. Divided by 2 times a. A is negative 1. So negative 150 divided by negative 2 gives me 75. So they need to make 75 cabinets. What is the maximum daily profit? Well, we found the x value of the vertex. Now we want the y value of the vertex. We've learned to do that. We simply take our x value and plug it into the function. So we have negative 75 squared plus 150 times 75 minus 4425. All right, I'm not looking forward to calculating that one in my head, so I'm going to use my calculator so I can be very accurate. So we have, now don't add parentheses that we don't need here. We've got the negative from the function. We're replacing x with 75, so we have negative 75 squared plus 150 times 75 minus 4425. Let our calculator evaluate, and we find the maximum profit is 1,200. Okay, piece of cake. So if you get a word problem and it's asking you about the maximum or the minimum values of a quadratic function, you're simply going to need to calculate the vertex there. Don't panic, just find the vertex. Negative b over 2a, f of negative b over 2a. All right, guys, best of luck on the midterm. If you feel good about these problems, you're going to be well prepared for the test. If you don't feel so good about these problems, feel free to come to the Outreach Center and sit down one-on-one with a tutor for some extra help. You may want to print another copy of this review worksheet and practice it a couple of times. And once you feel confident, go take your test. Best of luck to you on the midterm. Y'all go make me proud.